Hello everyone, this is Professor Robert Solis. Welcome to this next video lesson. What I want to show you in this C++ code is how to deal with bitwise logical operation. So, in other words, we are just dealing with single bits for AND, OR, as well as exclusive OR. So, you'll notice down here, if I were to drag and go down here a little bit, you'll notice that if I'm going to perform an AND operation for 2 bits, it's the single ampersand. If I'm going to perform a bitwise OR, it's that single vertical bar or the pipe. And then you'll also notice this caret, that's spelled C-A-R-E-T. That is the exclusive OR operation. All right, so what I'm going to do is I'm going to perform this operation after the user enters some data. We're going to ask if they want to do this again. And I just simply created a function. And so what I want to do is, it could very well be that maybe someone enters 101, so then I better enter 001 if I wanted to add 1 to that, say for example, to make sure that all the bits line up properly. So that's the whole purpose of this function. Let me run the program first so I can demonstrate it. So here we are being asked to enter what kind of operation we want. So I'm going to type in the number 1. So my first number is going to be binary 101, say for example. And then the next number is going to be 100, say for example. So you'll notice that since I'm ANDing these 1 and 0, well that's 0 because that's true and false. False and false, that's false. True and true, that's true. So that's why the answer is 100 if I were to bitwise AND each of these. Yeah, let's try it again. But this time we'll do an OR operation. So 101 followed by 100. All right, for the OR operation, true or anything is true. That's why we get this. False or false, that's false. True or true, that's also true. All right, and then finally, let's try an exclusive OR operation with the same number. Now remember, for exclusive OR, if the numbers are different, then the answer is true. So 1 exclusive OR 0, that's going to be 1 because there's a difference between the two inputs. Now these are the same, so that's why we have an output of 0. These are also the same, that's why we have an output of 0. Do you see those prefix zeros over here? That's why I have a function over here called fill in operands with prefix zeros. Just in case that happens, I want to make sure that all of the bits are aligned. So those first 2 bits were supposed to be 0, followed by the 1 in that previous example. All right, so let's go back to the top over here. Let me just briefly describe this code. Of course, I have a function, or a prefix of what the function is actually going to look like. Here's the function definition over here, and this is called the function prototype, of course. And I'm going to ask the user if they want to do this over and over again. Let me go ahead and have the user enter in whatever those numbers are, the bits that they're going to be entering. So first I ask the user, what do you want to do? Once I have that, let's go ahead and have them enter the number. Now you'll notice that op1 and op2 are strings. It could very well be that a person enters maybe something like 001, say for example. I'm going to treat these as strings because I'm going to obtain each of the numbers of those strings as if they were an array. So for example, if the user enters 101, well then I know that this is going to be index 0, index 1, index 2, say for example. So I want to be able to grab that, and I'll do that as a string. Okay, so the first thing that I'm going to do is I'm going to call this function called fill in operands with prefix zeros, and so it does exactly that. Now these, as you can see, are over here, so I'm going to send these values by reference. So when the function makes changes to these strings, they are going to make changes to the actual op1, op2 string that I send to this function because we are calling them by reference. So if I go down over here to the actual function, remember these are being received or being passed by reference. So the first thing I need to do is to obtain the length of each of the different operands. And then what I'm going to do is I'm going to find out the number of absolute, or the number of prefix zeros that I need. So I use the absolute value for that. If this one is larger than this one, or if this one is smaller than this one, I'm still able to get the size. And so that's why I use the absolute value to take away the negative sign. The counter is simply going to be whatever the number of prefix zeros that I have. This is going to tell me how many prefix zeros I need. So then within a while loop, I can put in the various prefix numbers via this while loop based on which number is actually larger than the other. Keep on increasing the counter or decrementing the counter until this is finished. Now, notice I'm not returning anything because we are doing this by reference. Okay, so I go back over here to the function call. Next thing I want to do is to determine now that both of these are the same size. This may be 1, this may be 101, but now that's 1 is going to become a 001. So this is going to be the same size as this after this function call. So I might as well just get the size of the numbers from op1 or op2. It doesn't matter. They're both the same size at this point after I call this function. Okay, so I'm going to have the counter be whatever the size of that number is, and then that's going to go through a while loop. All right, I'm going to use the string to integer function, and what I'm going to do is for this operand, which is a string, I'm using substring to get a certain variable or a certain number starting from position 1. All right, so actually this is going to be starting from the position and how many I want. Sorry, so this is the starting point. This is the amount that I need. So whatever counter happens to be, let's say the counter is 3 in this case. So 3 minus 1, that's going to be 2, which means index 2. So for example, if the user enters 101, so this will be index 1, this will be index, this will be index 0, this is index 1, this is index 2. So let me stop the code right here and demonstrate what I'm talking about. And I'll get rid of that. So let me go ahead and enter. Or start the program, I should say, and we'll just do and, that's fine. Now, I know this is not a binary number, but I'm going to do this to prove a point. So I'm just going to enter 1, 2, 3, and I'll say 4, 5, 6. All right, so here we are. So notice that op1 is 1, 2, 3. So if I expand that, look at that. The 1 is in position 0. The 2 is in position 1 or index 1. The 3 is in index 2. So that first number, that's really what I was trying to show. That first number is in index 0. Let me stop the program. Take this off. Go over here. All right, so if I entered 101, which is a valid binary number, this is index 0. This is index 1. This is index 2. That's a 3 number, or 3 in length binary number, which means that this is going to be 3. 3 minus 1 is 2, so that's index 0, index 1, index 2. So we are taking a look at that one character. That one over here means grab this guy. And so then the substring is going to grab that one, and we're going to convert that to an integer, and we're going to move that into a variable called bit. We're going to do the same thing for this guy. So maybe this is 100, say for example. We are about to grab this guy right here because counter is 3, 3 minus 1 is 2. All right, well, if the user entered 1, in other words, they want to perform an AND operation, then what I'm going to do is I'm going to use that single ampersand. Now, you know about the 2 ampersands, that's logical AND. This is bitwise AND. In other words, we are performing an AND operation between 2 bits. So I have bit 1 and bit 2. I've just obtained it, so that's going to be that 1. It's going to be that 0. We're going to perform an AND operation. I'm going to convert that to a string. I'm going to concatenate that to the result that already exists. Now, you'll notice over here I probably assigned nothing to the result. So initially that's blank. And whatever that is, this is going to be appending result to whatever this bit operation is. And then we are going to now increment counter, and now we're going to grab this 0 and this 0, perform the AND if the user entered 1, and we're going to append that, and then we're going to do this loop again, but this time we'll grab the 1 and the 1. We'll perform an AND operation. Counter will now no longer be greater than 0, so we're finished with that while loop. So we go to the output statement. If the user entered 1, then this is the statement that we're going to send out to the screen, the AND operation. Do you want to try again? If so, we go all the way to the top. Okay, so the same thing is done for the OR. And really the only thing that I need to describe to you is that over here, this vertical line is how we perform the bitwise OR operation. Over here, anytime you see this symbol, then we are performing what's referred to as the bitwise exclusive OR operation. So if these are different, it's true. If these are the same, that's false. And that's it. That's all the code. Very simple code fragment to determine the AND or exclusive OR in terms of bitwise logical operations. All right, so this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.